And that did happen. Welcome back. In this section of the series, I will show you how I managed to fabricate the frame and its corresponding fit assembly of my clearly different 3D printer. First of all, I elected to source all the components myself. I did it mainly because I could partially buy and print the components needed to build these assemblies. And secondly, I could spread the cost of building this machine into months. Bonus are expensive, yo. In the branding phase of this build, I elected to use the corner cube because I thought that it will be easier to build this printer using this. What I need to do is just to tap aluminum profile then call it a day, but boy was I wrong. When the aluminum profile came, the center hole is just too big for M5 screws. Side screw just pass right through, so I need to use M6. To be able to use this screw, a M5.5 hole is needed to be able to thread M6. Luckily, to solve this, I could just borrow a drill and bought myself a M5.5 drill bits to be able to tap for M5 screws. I tried to do it off camera without any guidance, and the result, let's say, not acceptable. The road that I took isn't straight with the volume profile. This is happened because skill issue. This is my first time drilling on my own after all. After a tutorial later, I created this, a tool that helped me drill straight to the point. Did I write this? Oh, straight to the hole and center. I made set tools using my one and only 3D printer, Photon Mono 4K. Then, fill the graffiti inside with two-part epoxy resin similar in the way that I do the Z-drive main part. Since we changed the screw size, this will screw up the corner cube. The corner cube could only fit M5 screws. I have tried to fit M6 screws, but the heads are interfering with each other while inserting in the screw. So I decided to fire the heads in a certain places like shown. There are three screws in each corner cube. The first I left it as is, then the second one I only fired the lower side, and lastly the third one I fired the lower side and the side. Those took some time to do though, there are 16 heads. The corner cube was finished. Now the frame assemblies. I had to use the corner cube and aluminum profile.
The aluminum profile is the same specification that was specified in the build guide, but what's different with mine is its color. I choose the original color because it is cheaper compared to black anodized one.
When assembling the frame, I choose to loosely attach the Z-rail with the screw and its the nut to the vertical aluminum profile first, then assemble the frame. Cause it's way easier to do it that way while filming it at the same time. Speaking of Z-rail, of course I have cleaned the shipping grease of the rail and its block before. Then we loop it with this oil. Yeah, I know it is not the correct oil for the linear rail, but that's the only one that I have before my grease came at the mill. So, when the grease came, I will upside block with that grease and kept loose at a safe place for now. I even don't know that the oil is wrong, I still did it just to prevent rust from building up. And if the grease didn't came, it's just a more frequent oiling schedule than using grease according to some tutorial I watch. This leads up to the seed drive and its corresponding item. The item was painted with resin. Then the cavity inside was filled with two-part epoxy resin. Then after it cured, I attached the hardware. This time not so much hardware, but if you could see that there is something different about my idler. The idler pulley is the wrong size. I misordered those. It's supposed to be 10mm width. The one is 6mm width. When the correct part arrived, I replaced it with the correct one immediately. Correction aside, it's time for the Z assemblies. The main part and its retainer, plus the stepper motors. All of the part was printed using SLA resin printer, then it got impregnated with epoxy resin.
For the shaft, I use 5mm round shaft, then cut it manually using hacksaw to 6 cm long, because my supplier do not want to cut less than centimeters long, and that took forever to do. Now, the shaft has been cut and trimmed. It's assembly time. What I'm doing here is assembling the blood drive assembly. Then attach side assembly to the drive main part and return it using the retainer and its 6 empty screws. Then tighten those screws diagonally. It is important to tighten them diagonally. Then attach the base and the rubber feet. For the stepper motor, I use NEMA 17 40mm length stepper motor. Since I do not have any stepper motor driver right now, I tested the motor using a piece of jumper wire. This jumper wire will short one of the coil inside, making the shaft harder to turn. Repeat for the other coil. A motor works. Next step is to clean those motor using an acetone. Then, give it an oil just to prevent rust. Then I attach the 60-tooth pulley upside down to the motor. For the pulley spacing, I use the tool that they provided. Then attach said motor to the retainer. Pay attention to the motor orientation. The connector is supposed to be in the same orientation as the wall. The last step that I did is temporarily attach the tensioner and the screws fall apart. Then it is done. Oh yeah, almost forgot to mention. I use plenty of rope while drilling and tapping the aluminum because you can have too much loop, can you?
Not really, because this happened to me. The bit caught on the aluminum profile and yanked it out across the room. Luckily, it didn't hit my camera though. I got really lucky this time. Now, I wash the aluminum using water and alcohol to clean off the chips and the oil used in the tapping and drilling process.
So all the components are ready now. It's time to assemble the frame. After seeing the video progression, I think it is better for me to shut my snout out and stop yapping. I add some music though to keep you company. Enjoy!
then done. But there is a small problem. The assembled frame is crooked and wobbly. I already knew this from the first time I received the extrusion, but I chose to keep a blind eye and proceed with the assemblies. My supplier didn't cut the aluminum square, hence making the frame crooked. To solve this, I decided to file the extrusion file using files. Duh. First thing that I need to do is to disassemble the frame, then detach the C-rails and keep them in a safe location. Then after breaking down inside and all of the aluminum, I felt the face of the aluminum flat eradicating high sides. I did it off camera because it's difficult to do while the camera is rolling. Next is frame assemblies again. Yay! This time I decided to build the bottom and top, then attaching the vertical side, then slide down the C rail in, on, to the vertical extrusion, then close the assemblies with the top side. Then this is the result. It's still wobbly, but I think it is acceptable for now. At least if the country is next, we know what happened and why. Well, next I did is to install the C drive assemblies. The camera doesn't show it, but I forgot to install the peanut, so yet again, disassemble time. I did it at least 3 times, so yeah. The other times I misinterpret the manual and put the peanut at the wrong place. So yeah. Yay! I test the fit using M5 screws and corresponding pin nuts, then I insert the stepper rectangle assemblies, then tension those two. Next but the least is the idle. It went without a fuss. Just attach the thing to the frame. I used different screw than the build guide because, yet again, I misread the part while ordering. I hope this won't affect the interference between parts.
And this is what it looked like so far.
Join me next time on the Kendry build. If you have any question, do not hesitate to mention it in the comment section below. Well, see you later, alligator.